Hello friends, in this video I will tell you how we can solve the MATLAB code in LabVIEW. For that I am taking an example of CSTR reactor. Here we will try to solve the model equation of the CSTR in LabVIEW. So for that I will go to the block diagram. In a block diagram I'll just go into programming, and in program we have this is a structure, and in a structure I'll go to this math script. This math script is nothing but this is your MATLAB synchronized window. So here actually whatever the code we have written in this MATLAB, so directly we can import it or we can cut and paste here actually. So here actually I'm taking copy and simply I'll just paste here. So now I'll just increase the size. Okay. So now here you can see we have two ordinary differential equation dca dt. So this is nothing but this is the dca upon dt. So that means what? So the first equation is nothing but this is your how the concentration is varying with respect to time. The second one equation, this is nothing but this is your how the temperature of the reactor is varying with respect to time. Now here we can see the three variables we have: ca, t and fc. These are your input requirements. So that means what? Here we have to assign or give the values of ca, t and fc. So here actually we have options. If I click here in this left hand side and add input, so here actually what we need the ca, so I'll simply write the ca. Same this way I'll add the different input. So different inputs we need t. So you'll see once I just assign here the t, so automatically you'll see the color will change into this dark black. Now next is your fc. So here this fc. So now we can see here I'll assign what is the minimum input we want from the user side and what would be the output. So the output is nothing but this is a dx dt. Or if we want to see the result of dca upon dt upon dt, then from here we can assign the output. So here actually output, these are the outputs which we can see. So here actually no need to congest the block diagram. So I'm just taking on the dx into dt, and I'll just from here take this indicator like that. So that means what? Now this output is over. Now here actually we'll see now we are not connecting this input. So for that the C and T, I'll just go back to the front window, and here I'll just assign first container. This is your array, and this in this array I'm just taking input, numerical input. So that means this is nothing but this is initial gas value. So this is initial gas value, and this initial gas value is like okay. So yeah. So here keyword we are given the two initial gas values. So we can write here Ca and T. So first one is your for Ca and second one is your for T actually. So from here I'm just fixing like that. Okay. So now go back to your block diagram, and from here we can see now this initial gas values is here, and from here I'll just separate out, or we'll say segregate. Sorry. So for that, I'll get index array, and from here I'll just connect this one, and we have the two outputs. So, okay. So now I'm just clicking here, and this is your CA, and this is your for T. So this is your labeling. Okay. Now from here, this FC, this is your initial guess value, and this is your first time. And now this FC, this is the input, which is again this one times we are given by the users. So for that, what I'm taking here, go to this application control, and no, go to here, and now we have variant, then variant to data. So now this is AppC. So I'll go back to here, and I'll just create one cluster, and this cluster is nothing but this is a constant, and this is for bold, and okay, now just fill it here. So again, this is our numerical value. I'll just take this in, and this is our FC. So now I'll go back again in this block diagram. So here we have this constant. So I'll just give this constant to data type. From here, actually, we have to see this is a variant input. So variant is our the data. So from here we can say this is control, and now this is control, and this control we can see here we have data like that. So I'll just connect to this one, and this is the thing, but this I think this is data. And from here, again, I'll just go back to unbundle. So here actually what we have a multiple constant values. So one by one we can extract from here, and we can give to the desired location. So from here we can see this is only one FC, and we will see the output is coming FC from here. So this FC we can connect to this one here actually. And now we can see our main block diagram is ready. And here whatever will be the minimum requirements of the input and output is here. This is over. So when you see this arrow, it becomes the solid. Now go back to the front panel, and from here we can see this is the differential equation. It is varying with respect to time. So here we will take one constant which is varying with the time. So I'll just take this is your time t, and this time t is ball. So now we can see I was taking time here also like that. And this is our output. Sorry. Now this is our output value. Okay. So now this is output, and from here actually what this is giving an array. This is giving some error. So I'll take this indicator, this error, and this error it will reflect here actually. Now this one. So from here like that. Okay. So now it's okay here. And one more thing here. Suppose we want to use this model equations and again and again. So what we have to create this sub-VI of this equation. So for that, what we have doing, we have to assign some input and output. So for here, actually, I'll just go back and from here we'll see what the pattern is good for us. So this is a pattern. So from here, as we know, this is for your input node and this is for the output node. So simply I click on this box and assign this initial. Again, next, this is for this data and this is for your this time. So now over, so this is your for input side. So here we can write input data. This is for this is constant and this is output data. So for the output data, let's click this one and this is assigned to this box and this is assigned to this box. So that means what now I have just created this is a GUI of your model equation and now I'll just save this one. I'll just rename, continue, and this is nothing but this is your CSTR model dot VIT. So now here we can see the CSTR underscore model dot VIT. Sorry, again save as, rename, continue. This is dot VIT. Okay. So now I have just saved this file with the CSTR underscore model dot VIT. So that means what? Now I have just created one GUI. So whenever we require to use this model equation, so directly I just drag out this GUI from there and we can use it. So this is nothing but this is your sub-VI of your of this CSR model equation. So now here actually I'll just little bit rearrange and by doing this. So for this, I'll just go back. So now you can see I'll just simply segregate the three different parts. This is for input, this is for output, and this is for the constant. So now thank you friends. In this next video, I'll show you how we can solve this model equation in your LabVIEW. Thank you.